This is a quick video about torque. Let's review what causes the linear acceleration of a mass and what causes the rotational acceleration of an object in the linear world and in the rotational world. In the linear world, it's force that causes the linear acceleration of mass. Well, what's new for us is in the rotational world, what causes the rotational acceleration of an object with inertia, rotational inertia specifically, is torque. So let's look at this example. This is the top view of a door, and a force is being applied in this direction at this point, a distance r from the hinge. We'll call that the pivot point or the axis of rotation. If this starts from a velocity of 0, we can accelerate it in this direction, causing a torque at that point. So being able to accelerate this object about its axis um, means we need a torque, and that's how torque can be applied. Now, in this example, let's say it's a similar example where we're looking at the top of a door, and there's the hinges, the axis of rotation, and we're applying this 5 Newton force 1 meter away from the axis of rotation. What I want you guys to do is I want you guys to think of torque as a rotational force. When calculating torque, always use the component of the force that will cause rotation. And that component of the force is the perpendicular component of the force. So the perpendicular component of this force is this 4 Newton force there. It's perpendicular to our object there. Okay? The horizontal component or the parallel component will not produce a torque. In other words, it will not make this object rotate in that direction, but that 4 Newton force will. So to calculate the torque, we take the distance from where we're applying the force to the axis of rotation, in this case 1 meter, the 4 Newton force, not the 5 Newton force. It's always got to be the component that's perpendicular, and we multiply those two together and we get 4 Newton meters. Now, if you prefer to use the equation that's given to you, they write it a certain way. They say R times F. And what that means, you'll find out later on in math, is that you got to draw your angle or find your angle relative to the R vector. That's why R comes first. So this is this line here represents an extended vector line from the R vector, which goes in that direction. This line represents the extended force vector. This 53 degrees is always measured relative to the R vector. So what we could also do is we could take the 1 meter length, multiply it times the 5 newtons, multiply it times the sine of 53, and we also get 4 Newton meters. Now that equation is great and all, but I really want you to conceptually understand that it's really this is the torque, the fact that we need the perpendicular component of the force. So we've got, in this example, we've got two forces, a 5 Newton force and another 5 Newton force. Notice that they are applied to the same point. We want to try to figure out which of these two 5 Newton forces produces the greater torque on the rod. So this one on the left, what you'll notice is its perpendicular component is 3 newtons, its horizontal component is 4 newtons. The one on the right, the perpendicular component is 4 newtons, whereas the 3 Newton force is parallel to it. So obviously it's this force here that causes the greater torque.